All right, this is video 11 for College Algebra, and today we're going to be talking about parent functions and transformations. So first of all, here are just 6 of our main parent functions that we're going to be looking at. I know you've covered linear, absolute value, and quadratic a lot, probably in past classes. But now we're going to be looking, we're going to be adding the square root function, rational, and cubic, okay? So it's probably important that you take a moment to recognize the domain and range of all of these and check out their x and y intercepts and their horizontal asymptotes and vertical asymptotes. That's what our HA and our VA represent. And most of these are not going to have horizontal asymptotes or vertical asymptotes, but our rational function. That's a big one there. So now, if we're going to be looking at the transformations of these parent functions, this is kind of our main form that we're going to be looking at, and we're going to kind of analyze what all of these mean. So first of all, our A represents a vertical flip, all right? If it is a negative number, so let's write, okay, if it's negative, it's going to flip over the x-axis. All right, and then if A is less than 1, it is a vertical compression. So I like to take the absolute value of A, and if it's less than 1 but greater than 0, so basically some sort of decimal, that is going to be a vertical compression. Now, if the absolute value of A is greater than 1, that's going to be a vertical stretch. And the way I like to think about these stretches and compressions are kind of like a hair tie. So assuming that this hair tie maybe was a quadratic, okay? A compression, we're going to push it together and it's going to make it wider. So our graph would become wider. And that's if, and so if it's a stretch, we're going to vertically pull this and it's going to be skinnier. All right, and it's kind of weird. A compression is a smaller number. So the smaller the number, the wider it gets. The bigger the number, the skinnier it gets. All right, and so that's one way that I like to think about that A value. All right, our next value is our H, and that is a left or right shift. So that's a horizontal shift. We move left or right, and I like to call it a liar. Okay, if it says -3, I'm going to move 3 in the positive direction. If it says +4, I'm going to move in the negative direction for 4. So if it's in those parentheses, it's a liar. Also, if it's under our square root or in the denominator of a rational function, that would make it that left or right shift. And our last one is our K value, and that shifts us up and down. And this guy tells the truth. So if it does say +7, we're going to go up 7 spaces. If it says -2, we're going to go down 2 spaces. So let's actually go and jump in and look at a couple examples of these. So first of all, let's kind of describe what these transformations are. All right, so I have a +1 in my denominator. So that means that I am going to go left 1. And my -2, that means I'm going to go down 2. And so for when we're graphing rational functions, I like to look at my parent function, and I see that my two horizontal and vertical asymptotes are at 0, 0. So if we shift those, that will make our life easier to graph everything else. All right, so when we shift these, so I'm going to go left 1. And when you draw your horizontal and vertical asymptotes, they are actually going to be dotted lines. And then we're going down 2. And then for me, I don't really mind how approximate you are. Just make sure that your graphs are in the correct quadrants. If you want, you can always look at your graphing calculator or Desmos and look at the actual table of the values. All right, our next one, we've got 2x squared plus 3. So for this one, we've got that a value, and so this would be a vertical stretch of 2, and we are moving up 3. So we're going to move our vertex up 3. And that vertical stretch of 2, we're just kind of changing the way we graph. So you can either multiply your coordinates by 2, or the easiest way again is just looking at your table of values on a graphing calculator. So here we can see our table of values, and I see, oh, okay, it's at 0, 3. At 1, I go over to 5. And then from there, we're actually off the graph. But this is going to be just a very skinny graph. All right. Okay, moving on. Absolute value. Now this one has a whole bunch of transformations. So let's start with just going in order. This would be a vertical stretch, and this is -3. So that also means sometimes you can just write -3, or you could say vertical stretch of 3, and it flips. This says -3, so that means I'm going to go right 3, and +1 means I'm going to go up 1. So we can start with the vertex of our absolute value, which is going to be 1, 2, 3, and right there. And normally, the slopes of both sides of our absolute value is just 1 and -1. So since it's 3, it's going to be 3 and -3. And we're going down, so this is facing downwards. All right, and so there we have our graph. And looking at our very, very last one, and this should say cubed. All right, let's describe our transformations. So we have a vertical compression, and if you just want to say like VS, or not too many people are picky on how they want that written. We've got a 1/3, we flip, and we go left 3 and down 2, so we've got a lot going on. So for this, we're going to move that center of our graph to -3, -2. And instead of going up 1 over 1, you know, to make our little S, we just actually go up 1 over 3. And this actually should be flipped because of that negative. All right, so this, you kind of got to draw this and curve it a little bit. But this is what our cubic function would look like. And again, it's always really important that you're just checking Desmos or your graphing calculator to make sure your graphs are correct. It's a really easy way to do that. So again, just make sure that you understand our parent functions and their different aspects of them.